Hello, wonderful people. We are back at Software Analysis and Design, and today we'll talk about activity diagrams. That's what we got going on. So let's see. Check in. How you doing today? My love is just a reminder, find your center. That's one of my favorite tunes when my day doesn't feel so great. So I thought I could put the link in here. So whatever's going on your end right now, see if you can put that aside for a little bit, and we'll just focus here for some time on a couple of concepts. And I promise you, whatever your mind is busy with while you're trying to do this thing, it's still going to be there by the time you finish the lecture. If it's important, it'll stick around, and maybe it's good to let it go for a while. So let's just find our center. Take a deep breath. Call your attention back to right here and now. Like Metallica said, nothing else matters. Let's do this. So we'll do a quick reminder of the UML diagram overview, so you know where we're at. And then we'll look into the notation for activity diagrams. And then I have a few examples for you. And at the end, we have an exercise. I think we're done with the assigned readings for this semester. I know we're done with them. I checked. So no more readings for now. And we just have a couple of modules to wrap up. So speaking of which, behavior models, we're close to done with those. So amongst the behavior diagrams, the activity diagram is the last one that we'll look at in more detail. And that's what's happening today. And then next week, we still have the component diagram on the structure diagram side. But for now, activity diagrams, here we come. So what do you see in this one? Here is an outline of a template for an activity diagram. So we have a black bubble on top. That's your precondition. That's where you get started. And then you have some kind of actor input that leads you to the first step. You may ask, what if the system starts by itself? What if there is no input from an actor? Like what? Oh yeah, maybe like the fire alarm system. In that case, the actor would be the sensor, and the sensor gets activated, and that's what triggers the first step. That's what triggers the alarm sequence. So after that first system step, you then get to a decision point where you have to evaluate whether a condition is true. And depending on whether it's true or not, you either go the basic flow if it's true, or you go the alternative or extension flow if it's no. And if the basic flow was true, then you go to step 2. And then after that, the two flows reunite. So the alternative flow is returning. And either way, you move on to step 3. And then we get to a joint. Those are the black bars. And then we have parallel activities. So we have step 4.1 and step 4.2 going on in parallel. What are things that happen in parallel? Maybe you have 2 different parts of a search that you can do in parallel. Or for that fire alarm system, maybe you have the blinking lights going on as alarm and a really annoying sound that goes off. And after that, the joint merges back together. So when the parallel activities are done, we're coming back together. And then we get to the end point, which is your post condition. So that was the basic overview in just one slide. If you're like, good, I'm all set, let's do this, then feel free to skip ahead to the last slide and do your exercises. If you want to bear with me for a little longer, we'll go through it step by step in a little more detail. So UML activity diagrams represent the dynamics of the system. So they show us the flow of actions in the system. They show the flow of control from activity to activity in the system. They show which activities can be done in parallel, and they show alternate paths through the flow. And then we have the notation here. So for the notation, we start with the activities themselves. So the activity is the core system of core symbol of an activity diagram, like add a new client. And it's a rectangle with rounded edges, and we'll try to give it a meaningful name instead of step 1 and step 2. And then there is transitions in between the activities, in between those steps. So the transitions show the flow, the sequence in between activities. And they are depicted with arrows with open arrowheads. That's your very basic part. And then start state is a black circle. It's the same symbol as in a state chart diagram. And then you get to decision points, which are shown by a diamond. And along with the diamond come the guard conditions. So for each branch that branches off that diamond, could be 2, could be 3, could be more, there is a condition in when this case is going to be picked. And then there is a final state, which is a black circle in a white circle. So here we add a new client and then assign staff contact. And then depending on whether or not there is a campaign to add, we'll add one and then we're done. For branching, what are we going to do here? There is an alternative notation for branching. So instead of doing the diamond thing, we can also just split that directly off the step. No campaign to add, campaign to add. And of course, after a new campaign is added here, then there should be an arrow going back to that very same end state as well. That is missing in this diagram. So let me just tell you, it should be there. The alternative transitions are then shown leaving the activity with guard conditions. And note, they don't have to be mutually exclusive, but it's certainly going to make your life easier if they are mutually exclusive, because how else are you going to know when you program it which way to go? And now you know there is both ways of how to do this. You can have the decision diamond, or you can do it without the decision diamond. You're going to come across both in industry. Both is valid. My personal preference, and this is personal, is the left one because it makes it a little more explicit. It points you more to the decision point with the diamond. But there are different opinions on that. For objects, we have object flows that are represented with dashed arrows. And then the objects themselves are represented with rectangles, and the name of the object is underlined. And you can optionally show the state of the object in square brackets. For example, here the campaign could either be active or completed. Then let's get to a couple of examples. So here we have a word processor. The activity diagram describes the workflow for a word processor to create a document through the following steps. We're going to start with opening the word processing package. We create a file, and then we save the file under a unique name within its directory. And then we type the document. If graphics are necessary, then open the graphics package, create the graphics, and paste the graphics into the document. So that's where you have that first decision diamond, graphics needed or graphics not needed. And then the flow reunites. And then if a spreadsheet is necessary, open the spreadsheet package, create the spreadsheet, and paste the spreadsheet into the document. Decision diamond, if tables are needed or not needed. And then again, the flow reunites afterwards. Could you do like the parallel thingy, the join and merge for those? For graphics needed and spreadsheets needed? No, nope, because it's not happening in parallel. It is something that is either fulfilled as a guard or not. So it's not parallel, it has to be the alternative path. And then we save the file, then we print the hard copy of the document, and then finally we exit the word processing package. So there's a first slightly larger example. And then I have 2 more. So let's check whether all of the part in here makes sense. No black magic involved. You take your steps from a use case description, from a more detailed use case description. Maybe your use cases are not all on that level where you see what is happening internally. So for activity diagrams, you can start describing them at a level of where you have your use case descriptions, and then you can start making them more specific according to what is happening within the system as well. So you can do it completely black box, or you can go a little white box under the hood. At this point of the course, we also want to go a little bit under the hood. Second example, process order. So once the order is received, starting again at the top with the black bubble, the activity is split into two parallel sets of activities. One side fills and sends the order, while the other handles the billing. On the fill order side, the method of delivery is decided conditionally. So you have the decision diamond, and it says either rush order or it says else. So these are mutually exclusive because it's defined by else. So if there is a flag click that says rush order, then we're gonna arrange an overnight delivery. And if it's not, then we will arrange a regular delivery. After that, you get back together with the decision diamond. Notice here in this diagram, the decision diamond brings them back together, whereas on the previous slide, the arrows just joined back together. So you will again find both in practice. My preference is to make the decision diamond again more explicit, say, yes, we're joining back together. And then finally, the two parallel activities combine to close the order. So from fill order and send invoice, from those two parallel parts, we're getting back together to close the order with the merge. So far, so good. Example number 3. Yes, all right, let's do it. Student enrollment. This UML activity diagram example describes a process for student enrollment in a university as follows. This is a very, very common example, and student enrollment somehow shows up in every single software design course. It's not the most exciting example, and at every university they're slightly different. But I am detracting, so let's get back to this example. So an applicant wants to enroll in the university. The applicant hands in a filled out copy of the enrollment form. And then the registrar inspects the form and determines that the form has been filled out properly. If it has not been filled out properly, then they get returned to the student and they have to go back to filling out enrollment forms. And the registrar then informs the student to attend in the university overview presentation. Sorry, I skipped the part about help available. So if they want help, then they can obtain help to fill out the forms. If it was incorrect and it was just a trivial problem, then they can still enroll in the university because it can be filled out right then and there or corrected. And if they choose to not use the help and just go back to do it themselves, then that's where they go back to filling them out by themselves. So after we're done with the bloody forms, and you know, forms are a thing. We got a thing for bureaucracy and forms. We like it because they give us the illusion of control over things. So from there on, once we have successfully enrolled, we're going to split into two parallel activities. One is to attend the university overview presentation, and the other one is to enroll in seminars and to make the initial tuition payment. So both of those can be done. And because apparently it's okay to attend the university overview presentation before you have paid your tuition, that's how we can make them parallel. So when you choose to make things parallel, you want to make sure that they are not making the system much more complex. So the idea is always, let's keep things as simple as possible. If they have to be sequential, we'll put them sequential. If they can easily happen in parallel, then we can allow them to be in parallel. That way there will be less dependencies in the code in between the individual modules. So think back to the lecture last week where we were talking about the principles of modularity, information hiding, and low coupling, high cohesion. Low coupling was don't have connections between things that are in different modules, and high cohesion was make sure that your modules are really tight inside so that they are really well connected inside. So modules, fairly loose coupling. Inside modules, fairly tightly connected. That's your high cohesion. I know that looks silly with the hands, but trust me, it helps me to remember. So maybe it helps you too. Good. So with that, we end the parallel part. We come back from our 2 parts into one, and then we're gonna finalize that one. Sweet. From here, there's one more thing. Basically, you're already good. You have the basic notation for the activity diagrams. However, there is one more thing that you can use to additionally structure them, and we'll go over when that is useful and when not. So swim lanes are vertical columns that additionally structure your activity diagram. They get labeled with the person, organization, or department that is responsible for the activities in that column. So in this example, we have a campaign manager, an accountant, and a client. So those are the different actors and systems participating in this activity. I'm going to start with the precondition and then record completion of a campaign. And then the accountant issues an invoice, and then the client has to pay the invoice. And then the campaign manager records the client payment, and then we're done. Now, what is that good for? What are those swim lanes for? Well, in a 4-step diagram, this is not so exciting. If things get more complex, then this matters because by organizing it in swim lanes, you have a very good overview of the control flow. So when is the control with each actor in this activity? Because as these diagrams get more complex, it may not always be obvious with whom the control lays in a particular step. And so swim lanes allow you for an easier overview of control flow. So a swim lane is a way to group activities performed by the same actor on an activity diagram, or to group activities in a single thread. And for modeling a staff expenses submission, here is another example. So a consultant fills out an expense form, and then that expense form gets initially submitted to the accountant. In case that object expense form, remember the rectangles are the objects, has an error, it gets sent back to the consultant, and then the consultant can correct the form, just denoted by sending it back to fill out. And then when validate expenses goes through as valid, then the expenses get entered into payroll. And then payroll services receives that object of the payroll file, and then they pay the employees, and then we're done. So again, swim lanes help us see the control flow, where the control is during the activity with which actor. Let's look at a direct comparison. So this time we're first going to look at the non-swim lane version. And here we have an example describing the business process for meeting a new client using an activity diagram without swim lane. So we start with a call client and set up an appointment. The appointment can either be on-site or off-site. Right now, probably most appointments off-site, so we're going to prepare a laptop. In the other case, we would prepare a conference room, and either way, we get to meet with the client. After the meeting, we're going to send a follow-up letter, and depending on whether there is a statement of problem included in that letter, if there is none, we're done. We're going right to the final state. So we send a follow-up letter, we're done. in case there is a statement of problem, then we're going to create a proposal as well. And for that, we have a UML note that says, see the activity diagram for creating a document. So there's another activity diagram hidden behind this little step. And then the proposal gets sent to the client, and then we're done. Now, if we were to throw Swimlanes in there, then we would see the control flow a little more clearly. So the salesperson sets up a call client and set up an appointment. And then we can have offsite or onsite. And in case it is onsite, then the corporate technician is going to prepare a conference room. If it is offsite, then the consultant will just prepare a laptop. Oh, notice something? Before, on the slide before, we did not know that there are these people involved. So it was not explicit that there was a salesperson, that there was a consultant, and that there's a corporate technician. So in this example, it becomes really obvious why it can be useful to have those swim lanes. And guess what? Because I like it when things are really explicit, I would often suggest to go with this one, especially if you're in the phase of learning activity diagrams, if you do them the first time. Because by that, you learn good style. And then if later on, you're like so golden with it and everybody in your team knows exactly what's going on, and maybe you work in an agile team and those diagrams get thrown away after the first prototype anyways, then you can still choose differently. For learning and getting settled, I would suggest to do some with swim lanes, which also means for your exercises. And then after the meeting with the client, we send again the follow-up letter. So the control goes back from the consultant to the salesperson. And if there was a statement of problem, then the consultant would create a proposal. Aha, before we also didn't know who creates what. And in case there was no statement of problem, we're already done. If a proposal was created by the consultant, they're also going to send that to the client. So now we know a whole lot more about that process than just with the previous one. And again, I'm saying it's good to practice with the swim lanes. It also depends on how your previous requirements documentation was. If you have other diagrams, say if you already have a sequence diagram modeled in detail, where all those responsibilities are clear, then you may choose to skip the swim lanes. If it's not documented anywhere else, I highly recommend to do it this way. I already said example from Agile, so let's look at an example from Agile Modeling. So let's check. We've already looked at examples from agilemodeling.com a couple of times. This one is interesting. So it's a whiteboard handwritten diagram. We start with filling out forms, and then we inspect forms, and once they're correct, then we can display something and then input the applicant information. We can search for applicants in the system. We can check that the applicants are listed. And then there are some decision diamonds. So we can display some potential matches, and in one case they can apply to university, and we can create a student record, and in the end all of that stuff merges back together. And then we can enroll, and then we can calculate the enrollment fees, display them, and then process payment and print receipt at the very end. Is this diagram good? No, dang, the headline already says what's wrong. So there's got to be something in here that's not so kosher. Something in here does not work the way we'd really want it to. Now, what is that? Let's see. Look at join versus merge. So we can enter the join part, but we can never get out of it. When you look at the logic in this diagram, then you can see that you'll either create a student record and then enter the join, or you could enter the join directly from display list of potential matches when the applicant is on the list. So one, but not both of these things will happen. The display potential matches is okay. The create student record is okay. One of them will happen. The problem is both of them are actually needed for you to exit the join. And so instead there should have been a merge bar, a diamond, instead of a join bar. Small but important difference. So while it's in parallel, if both of those things need to happen, then it's better to merge, to use a diamond to get them back together. So when you come up with parallels, then make sure you double check whether at the end of both of those parallel activities, it is required that both of them have been successfully completed. If that is the case, then you want to make sure that you have a merge. And if it doesn't matter if one of them gets fully completed or not, then you can still use the join. So quick summary of the notation. We have an activity that is used to represent a set of actions. And then we have a single action in a rectangle with rounded corners. We have a control flow that shows the sequence of execution with a straight arrow and an empty arrowhead, and an object flow. Ooh, that is inconsistent. That should be a dashed arrow right here. From one activity, if there's an object that flows, then the earlier slide said that should be a dashed arrow. Honestly, I've seen both in the past. What is good about the dashed arrow is that way you have a differentiation in between them. So that might put you on the safe side. You have an initial node that is a black ball, black circle, and you have an activity final node that stops all control flows and object flows in an activity or action. So that's when we're done. Second part, the object is a rectangle with just normal, not rounded corners. And then we have decision cards that have, we have decision nodes. Those are the diamond-shaped ones. And they represent a test condition to ensure that the control flow or object flow only goes down one path. So you have a guard X and a guard Y, and you can only go down one path. And for that, it makes sense that the guards are mutually exclusive. Otherwise, you're essentially implementing a randomization and you kind of throw a coin in case it could go both ways. And there may be good reasons for that. For the usual case, or for the majority of cases, you're going to have mutually exclusive guards. And then there is merge nodes that bring back together different decision paths that were created using a decision node. Then you have a fork node, where a split behavior uses a set of parallel or concurrent flows of activities or actions. And then you have join nodes that bring together a set of parallel or concurrent flows of activities or actions. So in most cases, you will have fork nodes and join nodes that separate and come back together using the same symbol. And I just threw in that example from Agile Modeling to show you that there are exceptions to that rule. For the majority of cases, you will probably have a fork node and then come back together with a join node. And only for a few exceptions, that may not be the case. And then last, you have swim lanes and partitions as a way to group activities that are performed by the same actor, or an activity diagram, or to group activities in a single thread. And that's all the notation that you really need. So you're pretty set. You're pretty ready to roll. So let's try this out. Mini exercise. This is for you to do right now. So grab a piece of paper and a pen. Yeah. Hit pause if you need to look for them. Good. An online flight reservation system must allow customers to search flights, make a reservation, purchase a ticket, and select a seat. Purchasing a ticket operation is verified by a bank. To do, draw an activity diagram of the system, give yourself 5 minutes, and then note the actions in red, they happen in a sequential order. So that means for them, the sequence is relevant in which order you carry out those steps. Also, I've already taken a little bit of the work away because I highlighted which parts are the most relevant out of this text. The text describes the activity or the main use case for the system. And what you usually do is you go ahead, underline all the nouns and the objects that they are connected with. So for example, search flight. Search is your activity step and flight is the object of what you're searching. Same for make a reservation. Make and reservation is the object. Purchase a ticket, same story. Purchase is your action and then ticket is the object for it, and select seat, again, same thing. Select is your action, seat is the object of that selection. And then the verification as well. So the thing on the side, add a new client, well, that's not the solution. This is just what reminded you that we're making an activity diagram here. So go ahead, hit pause on the video and make this little activity diagram. I'm watching. Have you hit pause? Now. All right, and we're back on. I hope you did hit pause. And we move on to here's your example solution. So we're going to do it with swim lanes because I said that's the way how I prefer to make it explicit, to make clear which part of the control flow is with the customer and which part of the control flow is with the bank. I'm going to start with the customer. The customer can search for flights and make a reservation without I, and they can purchase a ticket. And then the control flow gets passed on to the bank because the bank needs to verify the purchase. If the purchase is not confirmed, we're done, no booking. And if the purchase is confirmed, then we get to select the seat and then we're going to be done. Well done. I mean, I hope. Honestly, if you're not doing the exercises here, then you're just not going to get the practice and it doesn't help to just digest it mentally. You gotta try it out. You do the thing, you learn the thing. You don't do the thing, it'll always just be conceptual understanding. With that, I have a few more opportunities for you to try this out. So please go ahead and look back at the amusement park example that we've been using throughout a couple of the lectures and create an activity diagram for the main use case. This was about the entry ticket system for the amusement park. So model that and then go ahead and revisit the robot example that we've used last week and make an activity diagram for the two use cases. So this was a robot that is able to do the dishes for you and to do some handwritten messages. For both of those, you can make an activity diagram that breaks down a use case that you have specified. So if you want to do this, you go ahead and write down what the scenario steps are of the use case. So for example, robot doing dishes, you start with robot makes its way to the kitchen. Robot fills in the water. Robot adds soap. Robot turns off water. Robot grabs first dish. Robot makes it wet. Robot grabs sponge. Robot scrubs dish. Robot places dish into drying rack. and so on and so forth. And then you make an activity diagram for doing that. That includes all the loops, that includes the decision points, and that includes the guards of at the decision points, in which case is the robot going to do what? Like if the robot grabs a glass versus if the robot grabs a plate versus if it's cutlery or silverware. And then go through all those alternate routes. And then the same for making a handwritten note. And with that, you get quite a bit of practice in developing your activity diagrams. And with that, this round has been a little shorter, but I'll be happy to give you more if you leave some requests of what you would like to hear about in more detail, specifically about those activity diagrams. I know last week was quite a pile on you because of the architecture and design pattern lecture that was really long and really heavy. And if you haven't done all the recommended reading along with that, that is really crucial. I really, really, really encourage you to do the assigned and recommended reading along with that one. If you haven't done it, please revisit the lecture and go ahead and do that. All part of the course. All right. Thanks a lot, and I'll see you next time.